Right, so we're continuing the description of how this application works. We looked at the cell class, so we'll shut that one out of the way. We did that last episode. Let's look at champions next. So the champion class is relatively simple in that we've got some properties up here such as ID, name, title and max load. So these are all from the champions text file, which I obtained by going to the website that shows you all of the dungeon champions properties and so on. So they've kind of been manually written up in that text file. I'll just show that to you. Right, so here's the champions text file. So it just gives, for example, this is champion 1 out of 24. It gives the name, title, an ID number, and then the properties that were given from the website. I'll just show that to you. Right, so here are the champion list here. I don't know what that's doing up here. Let me shut that off. So this is a list of all the champions. All the data that's on here I manually and painstakingly put onto this text file, and then that's now read in. Get that out of the way, That's then read in the shared folder, which I'll show you in a minute, in order to populate these champion class with these properties. Now, because there is a lot of properties, I've put them all in a huge dictionary called stats. So all the possible things that they have, which are all like an integer value, it is all stored in this huge dictionary, and they're all been given the default 0 value. And so when a champion is created from the text file, these can be populated appropriately. Also, there is areas that the champion can hold things on his neck, head, etc, etc. There's also what's called a pouch, which has, I think, 2 slots, a quiver which has 6, and then an inventory that has I think it's 14. So all of these again are just created as string arrays and then put inside a dictionary. So we've got a dictionary of string arrays, and so we've got an awful lot of data that's stored there. So that tells you where everything that the champion has is where it is. Then we've got the door. So the door, again, name, key, the type, whether it's wood, the frame, whether it's a button, open state, breakable, toggled. So all fairly logical stuff is in here. So you'll find that most of the classes here are similar. So the floor class, again, it's key, whether it's toggled, visible, and so on. So this fits in with what the information that we're putting on tiled about various things. The items, again, these are fairly complicated because you've got a whole bunch of possible properties that an item can have, and this again came from the Dungeon Master website, which links will be put in the description. So again, I had to manually put all that. Let me just show you the text file. Right, so here's the text file. As you can see, an enormous amount of data that's put in there. Now, I'm just using text files at the moment because when I did this was still very much a work in progress, an experimental thing. As I developed the first level in Monogame, I decided to use an SQL database. So that's another piece of coding that we'll go into at some point to show you how I got all this lot in as a database. But for the time being, if we get that out of the way, it's read in from the text file and is used to populate the properties of an item. Now, player move, I'll come back to that in a minute. Wall writing, again, it's fairly simple. It's just the messages that are on the wall. This is line 1, this is line 2, for example, which I showed you on the previous video, and the constructor here and the name. So a relatively simple class. This is the bit that actually divides up the messages. If you remember, they were in a list like this, divided by a comma or semicolon. I think it was actually a semicolon. In fact, it was. Let's just change that. That was a semicolon. I'll find a semicolon there. And so this one splits them up. So it takes each of these messages and breaks it up into parts. So you've got, this is line 1, this is line 2, is then put into a string array, and then we add that into the list of messages up here. So that's relatively simple. Shared, yeah, I'll come back to shared in a second. Player move. Again, I'll come back to that in a minute once we are stepping through the program to show you how it works. Right, so of course this is console based, so of course it runs from program.cs with the main string here. So I've got this link here. I used this to find out how to read XML. There are a number of ways of doing it, but this particular site shows you how to use Linq, which allows you to use an SQL-like structured query language to extract the data from. It takes a bit of getting used to, but this I found really useful, and we'll go through how that's done shortly. But when the program kicks off, it sets the background color to the alternatives here, so that we can choose either a white or black background and a white or black. The reason for doing that is that when I print this up, because I do have, as usual, again I'll just show you that, is a PDF which will be on the GitHub. I'll just bring that through. Okay, so here's the PDF, and let's just drop the magnification bit on there. Let's put it up to 100. That'll do. So I didn't want the screenshots to be all full of black, because if I print this out it wastes a lot of toner. So I set this one to run with a white background and black text. So if we just get that back out of the way, so this one is set to the kind of default white background on black. So if I just fire it up again so you can see it, so that's the kind of how it looks like by default. By just simply changing these two round, which I will do now, change that one to black and this one to white, and then firing it up again, we've now got a white background and black writing. So this is more printer friendly, but it doesn't look quite so smart, so I prefer to leave it in its default way. So we'll just control those, and we're back to where we started from. So what this one does is it sets the console's background colors, width and height to the correct amount. Now this is where it gets serious. We're now going to start loading in the items using a shared file. So here's my shared file. So shared file is a static class, so this kind of deals with all the business end, whereas the program.cs is just the main player loop. And there it is, while player. So it's a relatively short piece of code, but the shared one does all the donkey work. So that we are going to load in the items here. So let's find load items. There it is, load items. So as you can see, there's a fair number of lines in this, 684 in here, but let's show you how it works. So the first thing to do is we want to get the data in from our text file. So if you remember, I showed you the text file. There it is. We want to load in items.txt. So it's using a routine called process text file. Now the reason for that is if you look at my text file, I've got gaps, empty lines, I've got comments here telling me what's in there. So it's important that those are not processed. So what I've done is to create this little process text file routine. So we'll show you how that works. So what you do is you pass in the file name of what we want to look at. In this case it's items.txt. We then create a new string, empty string list. We then read, or using file.readAllLines, standard process to read everything from the file name into this string array. Then what I wanted to do was to go through each string in the array, and if it starts with a hash sign, and if it's trimmed and the length is if it doesn't start with a hash sign and the trimmed length is greater than 0, then that's a legitimate line, and we add it to that list. So all empty lines, all those starting with a hash, are ignored, and then we get back a kind of pre-processed text file, which comes in is in our list of lines rather than the string array, which is given by the file.readAllLines. Then again, we're going to go through each of the lines, and I've given some examples here of the kind of readings you might get from the file, and then we're splitting it up into different pieces. So the equal sign here is the first one we break on, so we'll split it into Moonstone, which will give you the key, and then the properties of Moonstone is this lot. Then we split the properties side of it via the semicolons, which are here, and we get weight, manner, influence, whatever. So those come out, and then we check if it's already in the item dictionary. So let me show you where the item dictionaries are. They're all created at the top here. So we've got dictionaries of the door, floor, champion, item and wall writing objects. So these are all dictionaries of objects. The map here is the one that uses a text file to convert between the tiles found in the tiled map and what those tiles represent. So we use that in just one part of the decoding, which we'll go through shortly. But for the time being, you've got these dictionaries of objects, and the reason I use dictionaries is so that it's easier to obtain a particular object by using its key to see if it exists. So what we're doing here is to check whether I've already put an item of that name in, and if I haven't, then we create a new one, and that goes in to the dictionary there. So we use this thing here to create the key, using the index position and so on. So it creates a little key there. So each one of these items is then put in and actually created in the list of items, in the dictionary of items, and then we go through again the same item that we've just created and update all its properties, so that we update the properties here from this list up here. So this whole load items takes each line of text in turn, creates a new item object, and then populates the properties in that object. So I've left lots of comments, so you should be able to go through that in your own time and see how it works. So that loads in the items. Let's go back to program.cs. Similarly, now we're going to load in the champions. So that works on a similar principle. It uses the shared library again. So we can close off the load items, we're now going to load the champions. So again, it takes the data champions.txt file, processes it by getting rid of empty lines and comments, and then goes through each one again to add a new champion and decode the data in those lines, which is more complex in this case, because if we find the champions txt again, we've got like a champion takes up multiple lines. It's not all on one line. I don't know why I did it that way. I could possibly have put it all, I think because of the amount of data, I've just felt it was easier to separate it out. So that goes through a bunch of lines to create the champion, rather than just reading one line, getting all the information in it. So that gives us the champions and all the stuff they're carrying. Then we go back to program here. Then we're now going to get the level data, which is reading the TMX file from tiled. So this is how we're getting now to the nub of it. How do we get the data from the tiled map TMX file and actually produce a working project from it? So that's the next thing we'll look at it. So this is the shared get level data, and you pass in it the level that you want to open up. So this will be the name of the TMX file, so level 00, which is the first one, .tmx. And the first thing we need to do is to use a text file which allows us to associate the tiles in the tiled map to what does that tile do. So let me show you the text file. So there's only 88 of the tiles that are kind of mentioned in here, and what this does is it takes the tile, if I just show you on tiled itself, so this first tile, let's just increase the, I think it's Control Shift, yeah, there we go. Right, so this is the first tile, a plain tile. This one has an alcove on the north face. So if we look at the tile to item thing here, tile 1 is of type wall, so we've got wall colon, and then it's consisting of 4 parts. So the north, east, south and west sides of that tile are all wall. Whereas if we look at number 2, which had the alcove on the north side, this one is alcove followed by wall, 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 and then the next one was wall, alcove, wall, wall. So you can see how we have just done a kind of a text description of the first few tiles along here by just stating where the alcoves are. And obviously at the last of the row we've got, I think it was 4 all round. Yep, so this one has got alcoves all round, so that one should be of type wall colon alcove, 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 alcove. So let's just check that that's on the list. Yep, here we go, number 16, of type wall. And so you can see how this text file works. It identifies a tile and describes what sections of that tile can be used to get any information out. So we also need to read that file in, and we're going to use the map dictionary, which is this one up here, which is a string dictionary, to store the contents of that file in there. So this simply reads in the lines. Again, I've done this one directly. I haven't put any comments or anything in there, so it didn't need to process it, so we didn't need to pass it through the one that cleans up the thing and puts it in a list. So this is straight from the file because it hasn't got comments or anything in it. So that just simply adds all the lines into the map dictionary. Now here comes the clever bit in how do we actually read an XML file. We're using system XML Linq. So it's only one simple using. It's no special things that you need to load in. It's all part of the .NET libraries. So we're using xelement doc equals xelement load, and then you put the path in for the level. So mine is stored in the application path /data/level. That's just where I've happened to have put it. So that reads in the level, and then it uses these variables here to get attributes from the XML file. So we're looking for width, height, tile width and tile height. So if I just show you again, there it is. Let's wind it right to the top. So right at the top of the thing here, you've got all the data about the file itself, and then you've got width, height, tile height. So I wanted these specific pieces of data out, and so this code here does it by getting the attribute that gives that particular name. So if we had wanted, for example, let's go back to this file, if we had wanted the orientation, it's not really required, we could have just simply said, okay, I want the attribute orientation, and it would have returned us orthogonal. So that's relatively easy to get that information out. Now the next one, we're going to try pass because obviously these are strings, even though they represent numbers, the XML file gives them as strings. If I just go back to show you, for example, width equals 20 as a string, it's in quotes, so we need to kind of extract the digits from them. So it's using try pass, so that if it succeeds, it will then output the sizes to these variables here, which have been predefined up here. So those variables have been predefined as module level variables, and this will just populate them. If they're not populated, they will remain at their default 0 values. The next thing is to create a map. So we're using the an array for the cells. This cells object here, I think yes, here we go. So we've got a public static cell two-dimensional array. The question mark there is because the kind of auto help you do stuff suggested I make it a nullable, so I just did it. Whether it makes any difference or not, I don't know, because it's not going to be null, but that's why it's there. So we've now got down here, we're creating our 2D array of cells by giving it some dimensions. So the dimension is the width of the map by the map height, and then the nested for loops underneath it simply go through the x and y values of the map width, map height, and produce a new cell object just by passing in the column and row. So each cell object at this stage has only got its x and y coordinates in it. There's a ton of stuff obviously to go in, but it just creates them at that point. Now the next stage is we're starting to use this Linq, which I got from that website that I was linking above. I should put it in the description. So what we're asking here is we're creating a query or in an iterable list where we're saying from item in doc descendants, in other words, all the descendants, all the if we just get back to this, the descendants is pretty much everything in the document. So from the descendants, brackets layer, so we're specifying that the descendants have to be of type layer. So if we go back to it, we've got, what we're looking for is the word layer. That helps if you use the search and replace function, of course. So here's the first one. So it's this layer walls, and of course that one is the tag is ended here, and then you've got another layer here which is the floor decoration. So there's only two layers. So if we go back to the code, so we're looking for descendants layer, and then from those we want to select the item attribute name plus the item value. So once we find that this first bit where it's from item in doc descendants layer, so once we've found one, we're then going to select the name, in this case walls, and the data, which is this bit here, so that we will return in our iteration, we will find each layer with its name and its data in it. So that gives us the first iterable to look through. So I've given a quick kind of in the comments here a quick description of what it returns, and so we get those pieces of information, and then we're going to go through the query by just looking through it to find out what's in it. Again, I've left some information in the comments here as to what exactly we've found, and then how we're dealing with it to split it all up and get the name. This tidies it up to get rid of backslashes and so on. Again, it tells you how it's all used here, and then once we've got that layer, we send it to process data. So process data is down here. So this is an example of what is sent, the name and the lines from process data. So the name might be walls, and here are the lines, this string array here, which of course is exactly what you see here in the XML file. So you can see how we're now linking an XML content to code that we can deal with. So then we're going to iterate through this array of noughts and ones, and you can see the pattern of the zeros here are the empty cells, and the ones are cells that have got something in them, whether it's plain walls or walls with decorations or whatever, doesn't matter. We've got those in there. So this steps through each of those in turn and creates, so if it takes for example this first one here, the top, the first row, first column will be the first thing, as we've got a double nested for loop here. So it's going to find that, and it's checking if the cell type is not equal to 0. So obviously the first one here, 1 1, is not equal to 0, it's 1. So it's then going to process that. If it is 0, nothing happens, it just ignores it. So a 0 cell is ignored, but anything with any other number in it is going to be processed. So this is where it uses the map to try and get the value out of it. So rather than just talking about it, let's put a stop point in here and we'll run it. Okay, so we've now got to the first part here. You can see that the name is walls and the string of lines is this 20 strings wide, and there we are. We can see if I press view, oh yeah, it just says name is walls there. I was hoping to maybe get the entire listing out there, but it doesn't want to play ball. That's okay. But anyway, you can see the stuff. Everything is in there. So we're going to go through each one, and so we're going to start now with the first one. If I press F11, so the cell type is the X columns X, so that is 1. So we've got the cell type is of the first one here is 1. Then it says if the cell type is not equal to 1, which it isn't, so we're going to step into the next bit. We're now going to try and get from the map the cell type, which is 1. So if I hover over the map, this is the dictionary that we created that's got all of the tiled to item listings in it. So it tells you what's in each one. I'm not sure whether that view would show anything here. Let's see. Oh, neat. There you go. That's brilliant. So it shows you exactly all the stuff that was on that listing, and it's showing you all the possibilities that it could pick from. So that's quite handy. So we're going to try and get the value of 1 out from it, and assuming that we do, yes, we found it. And again, we're going to process now what we've got. So the let's get the string value for that. So the string we've got from it is this one that says the name is wall and the 4 items are wall, wall, wall and wall, all separated by a colon. So we're going to go now and process this. Now what this convert null to string does is that the data is wall, 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 wall. But some of the lines in my time to item here, for example, here we go, the raw wall writing, because in a text file it's difficult to put empty string and still get it to process. So I thought what I'll do is I'll put the word null, meaning that that's to be considered as an empty string. Probably not the best way of doing it, but it works. So what this little routine is doing is it's taking our data, and then it's going through to find out, just press the button on there, and to our data here. And if it finds that one of these is, instead of wall, is the word null, it will simply substitute it with empty string, and then it will return the image types. They're kind of processed out, so that, for example, here it would be empty string wall, empty string wall, if it was wall null, or sorry, null wall, null wall. That's what we're returning. So I'll just quickly go through that, and the return image types is a string of 4 containing wall, 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 wall. Okay, back we go. Then we're checking whether we have got the name is walls, which it is, and the first value of the data types here is also wall, which it is. And if it is, we're then going to update one of the cell objects that we've already created by using the cells X and Y data, and then the walls inside the cell. So let me go through this. So we're now going to look at the first cell in our object. So we've got an array of cells 20 by 19 across. So there's a lot of them. I won't need to scan all through them. Oops, where did my thing go? That's better. And then we're going to go into this particular cell and look at its walls property. So let's step into that. So we're now in the first of our cell objects, and we've gone into the walls dictionary, and we're now setting it, and we're going to set it with the data type 1 on here, which is wall. Let's go through it again. So we're now setting the other one. So if I underscore walls, as you can see, this was the kind of the default values that it was given when the cell was created. But now when I hover the walls, let's go view again, see if that shows me something. Yeah, nice. So we've got already the north one has been set to wall, and we're about to set the east one, and so on. So we're going to go through this 4 times. There we go, and let's check the walls again. And let's do the view. There we go. So we've set the third one, we're about to set the fourth one. So you can see how this this works. So we're now setting the properties of that cell with the walls. If the name had been floor decorations, we would have done the cell's floor properties. So I think you can see how this works now. So I won't go through stepping anymore, but you can see this first section takes these massive grids of numbers that we have only got two of. One is for the walls and one is for the wall decorations, and it processes them and extracts the data from it depending on the tile type, which is given by the number in the XML file. We look that tile type in the dictionary, we find out what it's supposed to take, whether it's walls or alters or a mixture of the two, and then we put that data into the to the cell object. So that one will process all of that. Now once we've done there are for each string layer in query, so we had two layers, we had walls and we had floor decorations, so obviously it's going to do both, because the for each one here will rotate through. And then we go to the next section, which is the get tiled objects. So let me put a stop sign there and we'll continue. We don't need that, we've finished playing with that. There we go. So we're now going to check out the doors by passing in the XML document. So the get tiled objects. Now again, we've got a similar thing. We're using this Linq thing, and what we're choosing this time is in the descendants object group, where the item attribute name value equals the object name. So what we're asking for is the object name here is doors. That's what we've asked for inside this document. So we're now going to select using Linq where doors equals the attribute value from something in the object group. So if we quickly look at our file here, we're going to look down until we find doors. Here we go, look, there's one here, object group, name equals doors. So this is going to return this one, all this stuff here, door 01 and door 03. So we're going to be looking at all the stuff here that satisfies that that query, doors 01, 02 and 03. I didn't put that up high enough. So we've got three doors. Let's go back and see what it's going to do when it's found them. So the next thing is we're going to run a subquery to see whether the object query has any properties descendants. So what that does is, for example, each of our door ones here has a properties, but further down we've got some here, look, such as champions. We have an object ID, but it doesn't have any properties. So this would be excluded because it doesn't have properties. So the object group has to have properties. So this of course would include things like decorations, wall actuators and so on. But of course the name there is not permitting those to be returned to the query, because remember, like SQL, we're specifying where something equals something else. So if we go back to the code here, so we're saying where the name value equals the object name, then we'd select the descendants. That was our first one. Now we're looking inside this object query itself. So we've already got kind of like a one SQL. We're now looking at the second SQL. So we're looking just inside what has been selected here to see where the properties and descendants are. So if the subquery produces no numbers, then this will be ignored. So if the subquery count is 0, then we move on to this one. So we should now, if I press F11 and step through, we've done the subquery, it's checking them out. Is there anything in there to look at? And it's not. So we're now we've skipped, because there's no subquery count in there. So we're now here, and we're doing yet another object query. So this one is, again, we're looking in the object group, name value equals object name, and then we're actually asking for the object descendants properties. So we're now asking each of these, which we were looking at up here for the doors, we're looking now specifically for the properties. So that's what we're using now to find those properties. So if we go through that, this one, right, and finally yet another query is from the for each of those that we've currently selected, we want to select the item from it. So let's have a look at the property that we're looking at. So the current one that we're looking at is this one here. Let's see if we can get a decent view. XML visualizer, that's handy. Let's do the XML visualizer. Oh, nice, I didn't realize it did this. You learn something new every day. Right, so it's now actually looking at what we have got over here. So there's our real XML file, and there is what we've actually selected. So we've got all the properties that I was looking at have now been found. So we can now, from that lot, we can get the properties name, its GID. Now the GID, if I go back to here, let's go back to this one. This GID is 74. It's that number 74 that tells you the number of the tile. So it's the equivalent of these numbers up here. But this is the number of the tile that this one is found on. So this object, the door 02, is on a tile of type 74. So the tile type again can be used to tell us what exactly are we sitting on. So we go through and get all these properties out, and then once we've got the name, the GID, the class, XY, and so on, we tidy them up a little bit using all these substring replaces and so on, so it just kind of cleans them up. And then we want to now find out from that GID number what exactly are we dealing with. So let me step through these queries. Right, so we're about to go in here. So name is door 02, the GID is 74, the X is 96, the Y is 160, then we've got the column X, 6, and row Y. So these are the coordinates, X and Y. So we know the map coordinates, and everything we need to know about it has all been extracted now. So we're going to pass in that we want to look for doors called door 02 with a GID of 74 at X equals 6 and Y equals 9. So we're going to call this set info from GID. Right, so what we're doing this time is to create initially an empty string array here. Again, we're going to use the map to try and get the value of our GID, which is 74. So if we look at the map, then we should be able to get, where's the non-public members? Strange, let's try this. That's better. So we're looking at the map. Let's do a view on that one again if we can. Oh, look at that. Yes, right. So we're looking at for 74, and so if we look for 74, there it is. It's a door track grate, door track grate. So it tells us that that particular door consists of 2 door tracks, of course, and the grate type. The position of them tells you whether it's north, sort of northwest, north-south facing, or east-west. So if you have a north door track and then a grate in the east position, then this would suggest that this door is running east to west. So you've got a door track again and then a grate east to west. So that gives us the direction that it's flowing in. So again, what this does is to go through if the type equals walls. It's not, it's doors. So we're going to look at the doors here. Let's F11 that. And we've just decoded the data. Come on. Oh, we're doing the convert null to string again. Let's flick through that. Let's get rid of the null values. Right, so we've got F11, we're on doors. So type equals doors. Now here's where we get a bit clever. What we do is to create a key for the door object based on the current level, which is 0 in this case, the X value, which is 6, and the row value, which is 9. So this gives us a unique key for based on the level and the coordinates of the level. So if we go in like that, our key is now 0-6-9. So that's the key, and that will be stored in the cell as the door key. Also, we're now going to we've created a temporary door object here, and then we're going to go through and check what the door type is and see whether we've got it already in there. Yes, we've found it. So or we haven't found it, sorry. So that value wasn't in there, so we're now going to create a new door object using the key, its name, which is door2, the fact that it's a grate, and then its X and Y coordinates. So this will create that new door object. I won't step through that, there's no need. And then we're adding to the doors dictionary this new temporary door object. So that's how we're creating a new object here, and then tell the cell the door object key. So what I'll do is I'll skip past that. There we go. Untick that. So we've now got temp is now a door, and it gives you all the details of that door in there, which is quite nice. And now we're going to put the door object key into our cell. So this is going to set the door object key, and then again in the cell we're going to go through and put the door type in. So again we can step through the cell. I'll do that 3 times. Okay, and now we can again just check the doors. View. There we go. So we've set door track grate. We're about to set door track again now, and then grate after that, and that will tell us what the types of what is actually on the wall there. The purpose of that is so that when we're visualizing this, we don't need to know all the details about that particular door at this stage, but we just want to know what we can see, whether it's a door track, a grate, or whatever. So that one is done. And that was the final one. And then we return whatever data that we have got out of it in case we needed it later on. So that's how the get info from GID works. It goes through each of the GID, which is a number of the tile, and then sets up the appropriate object depending on what it is. So we've got the same thing for alcove items, wall items. They all work in a very similar fashion. So that's what I wanted you to see. Now the next stage is, once we've created the, if I go back to program, is that we have got the level data. We're now ready to start showing it. So we set the cell placing player facing S. So let me just click a stop at that point. We'll continue. That's now finished processing all the data. It's all in there. This is where, if you notice, you've got the cell class here, dot player facing. So this is not a particular cell, this is the class static variable that we're changing. So if I press there, that will set the player facing. This is the static string inside the cell class. So it's going to give this player facing, which is this static string here, has now got the value s, and then it's going to check, depending what that value is, we're now going to reset the values of facing, left, right, which are static variables. So the whole cell has got those values. If I unclick that, you'll see that cell is in green. That means it's the class that we're looking at, not an individual object. Now the shared library here is going to be given the current cell coords, which are currently set at 0, 0, a new point 2, 2. So this was the default position I wanted this to start at, which we showed you at the beginning of, I think it was the first video, where we were looking at point 2, 2 on the map, and that's where we're going to start producing our description of what's around. Now the point viewport here is a new 2D array of points, which is returned by this procedure called get nearby cells. So let's step into that and we'll see how it works. So I've drawn these little diagrams here. So what we want is to get a 3 by 3 array of points in the cells around the player. So if the player was, for example, stood here, then these will be the cells to his immediate left and right, in front, left and right, and then 2 cells ahead and so on. This is plenty enough for the situation we're doing it with this. We're just looking at really what's just in front and to the left and right. We probably could even do with slightly less than that. But in the monogame version we need to look 4 cells up by 5 across, so a lot bigger array. But it just gives, what this does is to return the points or the points for each of these coordinates from the original map. So this is the empty array. These are the coordinates of our new point here, and we're going to fill them with values. So depending on what values it finds from the left or right or ahead or behind us. So the get corrected coordinates, let me just go through one of those. So we've got a new point, it's now currently empty. So we've got a 3 by 3, all of them empty, and then we're going to step through and get the points of the nearby cells. So what this does is to check whether the neighbouring cells, depending on which way we're facing, whether we're looking ahead, backwards, so slightly different depending on which way we're facing. The player facing is at the moment south, so if we step through setting up these ones here to find out what the maximum value of the width of the cells is and the height. So it's max x is 19, max y is 18, and then we're going from to 2. So that's the cell we're currently sitting on. From x, from y is the coordinates of where we currently are, and that's the maximum that we can go to. The whole purpose of this is to find out whether we are trying to move into something which is outside the indexes of the array. So the indexes are set initially to -1, -1, and then if we're facing north, no we're not, we're facing south, and then we're checking whether the from x and ahead, these are checking to make sure we don't go out of the range. So if we get a -1 in either our x or our y coordinates, that's a non-valid cell, we can't use it. So all this does is to check whether the coordinates are legitimate, and if it is, we then return them, and in this case we're sending a coordinate of a new point with values of 3 and 4. So that was the next one ahead, and that is returned. So I've just pressed F9 to pause the video for a second, and this popped up. I'd forgotten about this. This is of course the quick watch. So we've just returned the return value of our corrected coordinate, and here we've got them all. So that's quite nice. It's showing us what all the values are. So we'll close that, and we can continue. So this will go through all of them to populate the coordinates in the new array here. So if we go right the way through and let it finish its job, let's see if we can get the I don't want to stop the video. It might. Just going to try and get the return value in there. Let's see. I'll just do it. I don't want to interrupt things and destroy things. I'll play with that later. But anyway, we've got the value of our coordinates there now that we're going to use. So let's move on. So we've now got the viewport, and then this is our kind of our game loop. So while not player move quit, do this. Its next stage is to draw the screen, and this uses a new routine here. This is draw screen, so it passes in the viewport with all those lines on it, and then it does all the clever stuff with the console and drawing out to produce these lines and so on. This is fairly complex, so I will pause the video at this. No, I'll stop the video at this point, and we'll carry on another one because it's already about an hour long. So this will show now the drawing on the next one.